All right, welcome to part 2 of Lab Assignment 7, and this is the last FlowAlongSrf example we're going to look at. So this is a circle, obviously, and actually let's make it a little bit larger. So I'm holding down the Shift key while dragging on this scale to make it a uniform scale, and something like that. Okay, so let's take that, copy this. And actually, I'm going to sort of project snap to one of these sides and do that. Do it again. Project snap downwards. So I'm using the sort of object tracking and the intersection method to do this. And maybe here I want to, in this case, I'll turn off my perpendicular and just use the int. So in plan, it looks like something like that. Okay? So I'll take all three of these, the ones that I just made, and move this upwards. Move vertical. And same thing, let's snap to this height reference. Okay? Then take these two. Same thing, move vertical. Click somewhere. Doesn't have to be perfect, but just move that to the second. And this guy, vertical, and to the very top. Okay, so in plan you'll get something like this. Looks like things kind of align. I mean, it's a little off, not a big deal, but it'll sort of rotate around like that. Okay, now let's see what we get as a loft. Woohoo! So that is totally not what I was expecting. Yeah, it's sort of interesting, but you'll see that basically the seams of the circles are shifting a little bit as it goes across, and that's why this part is getting constricted, or it's, you know, sort of getting narrower at the bottom, right, where the seams are rotating. Let's just save that for further examination, further use, right? We'll see sometimes you get these. So what we have to do to actually fix that is that right after I run the loft command, I'll actually have to fix my seam. So in this first section, you'll see the seam is on the right, and because I just copied these, so it should all be on the right side of the circle here. And so you'll see that when I'm dragging or I'm clicking on this arrow, I'm just clicking it and letting go, right? It actually will snap to this end if you have your end snap on. So your job is to actually just find the end snap on these, right? So make sure they're all basically on the right side of the circle. And when you do that with the normal, say okay, then you'll get something that's more like this. Okay? Now, this is looking a little bit too stubby for me, so I'm going to select everything and let's just make this, I don't know, 1.5 times as tall. Okay, yeah, 1.5 times. Move vertical, snap to this bottom, and snap to anything on the ground, and that just moves it back up. So that looks a little bit more proportionally like, you know, let's say if it's a twisting tower. Okay, so this is what we're going to work with. Now there's another version of this that I sometimes do. If I just copy these things out to the side, I will sometimes take these circle profiles and rebuild them all together to a point count of 3 and a degree of 2, which gives me these sort of nice little rounded triangles, right? So you have to have a point count of 3, a degree of 2, say okay, and you can try that and see how that works out. Whoops. Loft. Now the same thing, we're having the trouble with the seams, right? So you have to do it again and basically try to align things based off of, you know, what sort of rotation you're really looking for, and basically slide this until it snaps to an end point. So that, and I think that's an endpoint too. So that's an endpoint, right? It's basically in the same locations as before. Okay. Oh, this one is actually flipping on itself. So you would want to reverse that. Flip the direction like that. Okay. So I basically clicked on the arrow to switch the arrow direction. So okay. So you'll see this is basically the same thing, except it's a sort of rounded triangle corner with flat faces on some sides, right? Okay. We can also basically move this out of the way, save it for later use. All right. So the version I'm going to work with for now is this, and we're going to look at something called, and that was the circle and rebuild. We're going to do something called FlowAlongSurface. So the command we're going to look at first is actually this one called UnrollSurface. And it's basically what it means. It takes a surface and tries to lay it flat, like a piece of paper, as if you're trying to smush it. And the reason I have boxes down here for each and every one of these is that you can actually do it to all of these. So UnrollSurface. So you can select this. And don't explode it. Those are just options that help you kind of label things if you need it. Right click, and you'll see that this basically happens. Now, in this case, because the sort of rotation makes it like slightly unflat, so you'll see that some of the surface start to overlap, right? If we, let's say, unroll surface, this one, then you'll see that basically if you actually, because this is grouped together, if you explode it and cut these out individually, you would be able to actually reassemble this, glue it back on the seams, right? In this sort of exact configuration. This is the bottom of that poly surface, right? If you were to cut these shapes out, you would be able to glue it back into this shape, basically. So that's what the UnrollSurface does. It will have more errors in this sort of twisting shapes, but if it's something, let's say, like for a box, right? This, as you can imagine, can be unrollable like that, right? And this works for any poly surface, especially for poly surfaces that have flat surfaces. So even something like this, like a torus, right? I can unroll it into its component parts. They might not be aligned in the way that we like, but you know, this is the outer wall, this is the inner wall, and these are the two rings, right? So it's really cool in that way, in the sense that, you know, you can have fairly complex, you know, poly surfaces and have Rhino basically try to figure out for you what those individual surfaces are. Whether or not they're linked in the right sort of orientation sort of just depends on whether or not these are things that can be unrolled correctly or not. So that's really cool. This is basically a way you can kind of reconstruct something like that from paper or on the laser cutter, for example. Now let's try doing it to some of these. This guy. And you'll see the unroll surface, you know, always unrolls it and puts it at the 0, 0 point. So say okay. Whoops. Select surface, this one. And you'll see that this one, it actually tells me unrolling doubly curved surfaces will produce inaccurate results. Okay, and that's probably true of this guy as well. So there's a different command in Rhino 5 called smash. Now, smash is the inaccurate version of UnrollSurface. UnrollSurface tries to stay within a certain tolerance, which means that these are actually accurate. Now, obviously, when you're taking something like a ball, right, or a sort of spherical surface that has double curvature, it's basically impossible unless you cut it open. Like the Mercator projection, unless you warp it to be able to flatten it. Now, Smash basically is a way where Rhino will basically try to ignore some of those inaccuracies. So we can do it to this, and it will actually tell you if you come up. Let's see. Calculating starting area. Enter, right? And you'll see in this, it will tell you that, okay, the unrolled surface, the sort of flattened surface of that, is 3% larger after unrolling. So it's a little bit, it's basically 3% off, okay? So let's try it on this one. Smash, enter, enter, like these settings, explode equals no, labels no. And this one, because there's more curvature, it says it's 17% bigger after unrolling. So obviously this is a lot more inaccurate, and you won't be able to actually sort of try to roll it back into its correct shape. It'll be a lot more inaccurate compared to these, or ones that are you can do with just UnrollSurface and not Smash. Okay, so that's the sort of difference, and actually I should change the text on this. The same probably goes for this. So if you smash this, it's 6%, right? There's a sort of deviation of 6%. Let's try it actually on this sort of pipe that I just made. Let's see if unroll will make. It won't work, right? So basically, if you have a doubly curved surface, at least one surface, then it can't be smashed. Okay. If you have a doubly curved surface, you will have to use Smash for the most part. So let's see if it works on this. Nope. Or this. Nope. Right. Okay. So all of these are actually Smash. And you'll see this one is actually that. Right. So that's what we want. And try that one. That's that. Right. Now these are fairly similar because you'll see this is basically unrolled and it's sort of split apart at its seam, right? So this is basically that, and it's really easy to understand. Okay, so that's the unroll and the smash command. Unroll will work better for poly surfaces that have flat faces. Smash will work better for surfaces that have double curvature going in both directions. Okay, so we're going to take this and I kind of want to illustrate this point really quick, so I'm going to show you how the command works. Alright, so I've just made two simple surfaces. This is using the same method that we did in the last video, right, to kind of make the Sana EPFL. And I just copied it and sort of modified the surface geometry. So this is actually now something that's completely different, right, from what it was before. Okay, so it's sort of warped. And this command, FlowAlongSurface, is basically a way where you can take, for example, let me just take some of these, copy it over. And I'll just sort of, actually that's too much. Okay, something like that, right? And I'll arrange a geometry on this. And this actually works for both curves and objects, although objects will take a lot longer to run. So you can run this command called FlowAlongSurface, right? It will ask you for the objects to flow along a surface. So these guys, enter. Base surface, select near a corner. So I'm going to select in my, let's say, upper right corner, since these are sort of parallels, upper right. And then target surface, select near matching corner. So I'll click on the upper right corner of this. And so you'll see what it does is basically it interpolates over things. Okay, now this actually is a command that you can do with record history, and so I'm just repeating the same commands, and so you'll see that basically you can start to see the correlation between these two in terms of their UV coordinates. So if I move it to the center, then this reprojects to the center. If I move it to the upper right, it'll reproject to the upper right. If I move it out of the boundary, it'll move out of the boundary as well, right? So that gives you a pretty good sense of how this command works. It basically takes a base surface and reprojects it to another surface. Now, for the most part, you want these surfaces and their basically their UV subdivisions, or like when you rebuild it, this UV subdivisions to be more or less identical for the best results, so things will actually map correctly. And so this is actually a way where the pattern actually updates into this is the control surfaces and this is the target surface. Okay, so that's the basic theory behind this command. All right, so that's why, this is exactly why we were actually using this and taking the unrolled surface version of it, right? Because then we would know that when we take this pattern and try to project it onto it, it will wrap a certain way. So this is probably a little bit large. Let's move this slightly into the corner. And it's okay if the pattern kind of comes out a little bit. And I'm actually just going to scale this. So scale using somewhere around this lower left corner. And I know that we scaled that tower 1.5, so let's just do 1.5. And that's a little larger. Okay. And because of that, we might actually want to scale this a little bit in this direction. Basically, kind of move it so it overlaps over it. You can decide whether or not you want to maybe a little smaller, so the top and bottom kind of will fit within the boundaries. And maybe a little bit more. And just so I'm sort of just trying to center the top and bottom. Okay, and don't worry about the left and right. Okay, so in this case, I'm just actually going to delete this row. I'll delete anything that's sort of out in space and doesn't actually intersect. Some of these actually do a little bit. All right, something like that, who knows? Let's see what we get, okay? Let me move this back up so I have a larger screen. All right, FlowAlongSurface without the history enabled, because when you have a lot of stuff, it will actually bog down your system. Select objects to flow along a surface. So I'm going to try to select all this, and I'll do it in 2 goes. Once, like that, and twice, without selecting the surface itself, right? That's important. You're not selecting the surface itself, it's just these patterns. Enter. Base surface, select near a corner. I'll select the lower left corner here. And then target surface, select near matching corner. So I'll click on the lower left of this thing. And you'll see that you'll get something like that. Okay? So you'll see that that top is actually probably one of these edges, right, where there's a tiny little seam on both sides. And then this edge is probably this bottom part, and this top part where we have more of this jutting up is actually the top part over here, right? So now these curves are all matched to this original surface that you made. Okay, so I'm going to take this and basically copy it upwards. I suggest you do this so you can kind of show the process, but also have a fallback just in case something fails. It's always a good idea to copy something over if you're going to do an operation on it that's potentially destructive. Okay, I'm going to remember actually to take out, I want to delete you want to delete these curves, your profile curves, out of it, so they don't become part of the thing. You want to take out that one. There's one in the bottom, this one, and there's one on the top, right? Take those or remove those so it doesn't affect our next operation. So what I'm going to do is do the split command. Select object to split the surface. Enter. Select cutting objects, all these curves. So I'll do it in 2 passes. Once and twice, like that. Enter. And it'll think. Let it split. And you'll see that it split everything into individual panels as well as that overall, let's say, bone structure. Okay? Okay, so now we're going to take this central lattice structure and copy it over 300. So we have a duplicate. All right, so we know this is the relative distance between these is 200. Okay? All right, so we're going to do something here called offset surface, right? Remember, offset surface. It's going outwards and distance. Let's give it an offset distance of 2. Okay? Solid equals yes, make sure. Corner is sharp. And it'll think for a while, because this is a relatively complex calculation. And you may want to save before this. All right, so I had to wait maybe 30 seconds to a minute for that, but just let it run. It'll eventually come out and you'll get a thickened sort of lattice structure. That'll become the exoskeleton for this tower. All right, now here what we want is actually to get all of these panels, and we want to actually put it on a different layer. So let's get this in. We'll get this lavender layer, call it glass, right? And what we want to do is actually select all these. Now, there's a lot of stuff here. There's this, so we're going to use our hide show commands. So this sort of exoskeleton surface, let's just hide that. Now there are curves and surfaces here, right? So what you want to do here is actually use your selection sets, right? And here you can use select curves. Select curves will select everything, all the curves in the scene, okay? Now, what you want to do is actually zoom out a little bit and hold down the control key as you do this. So you are deselecting all the other curves from the scene, and you're just selecting the curves that are here, right? That's what you want to do. And then just hide them. Okay? Now you're left with all these, which are just the surfaces. Okay? Now, if you select all these and change them to the glass layer, so change object layer, all right? And then we can move it, right? And you can decide whether or not you want to give these thickness or not. Like it's the same thing, you offset surface. 300, I think, right? And so it'll match perfectly into place as your glass panes. Now it's still missing one thing, which is the floor slabs, right? So let's see, what was the overall height of this? Let's take a look. 360. Okay, so for a tower floor, let's say 20 feet of floor, so that's around 18 feet, 18 floors. So let's just do 20 then, all right? So what we're gonna try to do is we're gonna copy this out again, just the surface. All right, and then we're gonna run a contour command on it, right? Contour, select the object, enter, we want a base point. So try to click on one of these base points here. And then I'm gonna actually switch to one of these side views, zoom out a little bit, and make sure that I'm clicking in the orthogonal upwards direction, right? Vertical direction. And then distance between contours of, let's just say, 18. So it will make basically a series of floors, right? With this still active, let's just pull it out. 100, or maybe, well, 200, a total of 200, right? So this is what you're getting, right? All right, take all those circles and make a planar surface, right? So this guy, surface from planar curves or planar surface, okay, right? And we actually know where this should go. So you can, if you want, if you need a sort of point of reference, you can move it back, like negative 100, right? Oops, sorry. You can delete these curves, just select all these and do negative 200 to move it back into the exact right location. And there's a seam here, so you can copy all these over and match it to the inside seam that's over there. Right, so I was copying it to basically the inside point of this right there. Okay, so I'm matching it there so that it'll match perfectly. All right, now these floors don't have thickness, so I'm going to use my selection set again and use this guy called select last created. So it will actually just select all the things I just made, right? And then let's extrude surface. Up or down? Up. Let's go down a little. Yeah, let's go, let's say negative 2. Is that enough? Kind of, yeah. All right, negative 2. And delete your original surfaces while it's still active. That's kind of what you're going to get. And your weird crazy tower is done. All right, so that's just the end of part 2. And you can try this sort of technique on some of these other surfaces, although you will see that your results may vary. It will usually work better on something like this, whoops, or something like this. Basically, where the surfaces are a bit more regular. You can do it on these, except because the FlowAlongSurface will only work on one surface one-to-one. So what you would have to do is actually, for this guy, you would actually have to do 1, 2, 3, 4. You have to do it 5 separate times by selecting the pattern and mapping it over 5 different times, right? So it's sort of a pain in the behind. I would just try to do one of these single surface versions. All right, and eventually, so this is what you want to take into the next step, which is part 3 of lab assignment 7, where you're going to put this into context and then do a rendering of it. Right, so see you guys in the next section.